Welcome, y'all. All right, back to the last section, chapter 12.8. Let's talk about areas and volumes of similar solids. So we talked about similar polygons back in chapter 11, where we're just comparing two shapes. So circles are similar. Now, to do similar solid, first things first is we have to find the scale factor. So scale factor, to figure that out, is just compare similar parts. So for example, here, the two parts of this are similar are the radius of the circle. So we compare it. So the big one is 14 to 10. We reduce that. That gives us a 7 to 5. So our scale factor is 7 to 5, or can be written as 7:5. All right, so if we were looking for another part, for example, we're looking for the height of this one, we just take our scale factor, 7/5, and set that equal to the proportional parts. So if I'm saying 7/5, I'm saying this to this, then when I set up the next ratio, I do this height to this height over here. So h/35. And then from here, it's just simple math. We just go ahead and cross multiply. So we get 5 times h equals 7 times 35, which gives us 245. So then to solve for h, we divide both sides by 5. We get 49. So our height of our bigger cylinder is 49. All right. So scale factors. We understand the concept of scale factors. So let's go and now look at what's new about this. So anytime you're doing scale factor and you're trying to find one part or the other part, you always use the regular A to B. So we did as A over B, but you can do it A:B, some version of that. Now that is true for any kind of perimeter or height or length with one dimension, one length. But if we're doing area, whether it's base area, lateral area, or total area, we have to do a square, b square. So that's what we did last chapter, where we were doing the area of two different triangles or hexagon or anything. We were doing a square to b square. So we take whatever it was, our normal scale factor a to b, and we square those. And then we're doing volume, because volume is three-dimensional, so we do a cube, b cube. So volume is three dimensions, so you got to cube your scale factor. So for example, let's say our scale factor is 2 to 3. If we were going to set up a proportion with the proportion, we take our scale factor as it is, and then we square it for surface area, and we square them. So we 2 square colon 3 square. So when we do that, we're getting 4 to 9, or you can write it as 4/9. Now, when we do the ratio for volume, we take that same original scale factor, our 2 to 3, and we cube them. So 2 cubed, 3 cubed becomes 8 to 27, or you can write it as 8/27. Well, let's use those. Let's see how that's used. Let's take this problem right here. So we're looking for the height, the slant height, the total area and volume of the bigger one. But to do so, we kind of have to find the parts of the smaller one. Now, I throw in this problem like this because I wanted to take an example. This is going to kill like 3 examples at one time. So we're going to do the example for all these at one time. So we don't have to do a bunch of different ones. But let's go ahead and do it. So we need the height. So we first need the height of the small one. So these are our small cones. So the height of this one is 36. And then we need the slant height, which we use an L to represent that. Well, slant height will be right here, and we don't have it on this particular cone. So let's go ahead and find it. To do so, because it is a right triangle form here, we do a Pythagorean theorem. We're going to do 15 squared plus 36 squared equals our slant height squared. So as we square these numbers, we got 15 times 15 is 225 plus 36 times 36, we get 1,296, and that equals our slant height squared. We add those two, plus 225, we get 1521. So 1521 equals our slant height squared. Now remember, from this point on, then to find our slant height, we square root. So you get rid of a square. So that cancels out, leaving it just L. And that, when we do that right there, that gives us, let me do it real quick, 39. So our slant height is 39. All right. So then we need our total area. So our total surface area, so either T area or we just put area. So to find our total area, you remember, for area of a cone is pi RL, which is the lateral area, plus the area of the base, which is pi radius square. So pi RL plus pi radius square. So let's just put the numbers in there. We said this was 39, so we'll do pi times the radius 15 times the slant height of 39 plus pi times the radius square 15 square. Let's see what that gives us. So 15 times 39, we get 15 times 39. We get 585 pi right there. And we're going to add the value of our 15 squared. So we do that 15 squared, get 225 pi. We put it together, plus 225. We get 810 pi. So that is our area for the small cone, 810 pi. Now, we're going to keep it in terms of pi. That way, we deal with smaller numbers, not as exorbitant and huge. All right, and then we got to find our volume for our small cone. Remember, volume for the small cones, it's area of the base times the height divided by 3. Now, the area of the base is a circle, so we'll do pi radius square times height divided by 3. Well, let's substitute those values in there. So it'll be pi times 15 square times 36. So this is where we use the actual height, not the slant height, all over 3. Let's reduce it. We can reduce these numbers. That way we don't have to worry about getting such huge numbers. 3 goes into 36 12 times. Okay, so we're left with pi times 225, which is 15 squared, times 12. Let's go ahead and multiply that. So 225 times 12 gives us 2,700 pi. And we're going to leave the pi on there. Again, keep it in terms of pi. If we want to figure out an exact number, whether they want an exact number, this is it right here. If they want an approximate number, whether 1 decimal, 2 decimal, or 3, then you go ahead and multiply it and round it then. But try not to round it too early. All right, so we have all the parts we need of our small cone. So when you do your homework, they'll probably provide it. They won't have all of them, but I wanted to try all of them, how they work. Get an example of all these volumes, surface area, heights also. So we're going to find all those exact same parts, but not for the big one. So I'm going to erase this. Hopefully you wrote it all down. So we're going to do this in red. So we want to find the height. There we go. The height, the lateral height, the area, total area, surface area. So I'll put total area. And volume of the big cone, So we have the radius, we got to find the height. So to do so, we set up a proportion. Now let's compare two parts. To do proportion, we compare two parts we know. Well, we know the 15 and we know the 25. So they're similar parts and they're proportional to each other. So we'll say, hey, 15 over 25, right? We reduce that, we get 3 over 5. So this is our scale factor right here. This is our scale factor that we will be using from here on out. So let's start with the height. So scale factor the height, we do the scale factor 3:5. As this height, since we did 3 to 5, we do this height to this height. So 36 over height, what we don't know. So we cross multiply that, we get 3h equals 5 times 36, gives us 180. We then divide by 3. H equals 60. All right, that was simple enough, 60 right there. Now let's find our slant height. Same thing right here, since it's at one dimension, a slant height. So we do the same thing. We set a proportion 3:5. As this slant height, 39, is to this line out here, L. We cross multiply, we get 3L equals 5 times 39, gives us 195. We then divide that by 3, we get divided by 3, L equals 65. All right, so we got our slant height. So we got our height of 60, our slant height of 65. Let's find total area. So instead of having to redo that whole formula, the pi RL time plus pi radius squared, let's do the proportions. Now, for area, since it's two-dimensional, we take our scale factor and we square those numbers. So 3 squared, 5 squared, that gives us 9 over 25. So this is the scale factor we're going to use. All right, so we do 9 squared is to 25. Oh, 9 is to 25 as the area of the smaller cone, which we say was 810 pi, is to the area of the bigger cone, which we don't know. That's our area, our L. So we cross multiply, we get 9a equals, now when we multiply this, we're going to just multiply the 25 and the 810. We're going to leave the pi as pi, so we're not going to include it in the multiplication. So we take 25 times 810, we get 20,050 pi. Okay, then divide by 9 both sides. Again, when you divide this, only input this in your calculator, just this part right here, the 2250. So A equals 2250 divided by 9. You end up getting 2,250, and that is with the pi included. So 2,250 pi. That's our total area of this whole count. There is no big old formula doing it, just a little bit of cross multiplication and dividing. Let's do our volume now. So an example for our volume, do it one more time. So I'm going to erase this, kind of give myself a little bit of space. Does it ever work? So there we go. All right. Hopefully you wrote that down. All right, so for volume, we take our same scale factor at 3 to 5 and we cube them. 3 cube, 5 cube. So 3 cube gives me 27. 5 cube gives me 125. This is the scale factor for volume. Volume scale factor. So we set that proportional now to the volume. So the volume of the small cone right here was 2,700 pi. So we're going to put that over the volume of the big cone. Just like before, we cross multiply. So 27 times V is 27V. And again, 2,700 times 125. You kind of leave the pi off that. You get 337,500 pi. All right. Again, we leave the pi off just because we want to keep pi as pi. We then divide both sides by 27. Divide both sides by 27. You end up getting volume equals 12,500 pi. So our volume is 12,500 pi. Now, if you want to go the old way and do area of the base times the height divided by 3, so then you'll do pi radius squared 25 times 60 and divide by 3. You're more than welcome to, but this kind of saves you a little bit of time when you don't know all the parts. Let's say they give you the scale factor and then they just give you the volume. You can automatically find the volume without having to do the formula, without knowing the radius of this or the height. All right, so that's how you'll see it in your homework. They'll give you a scale factor, they give you one area, you have to find the other area. So make sure you square your numbers. You take your smaller scale factor squared over your bigger scale factor squared. Let's do one more to kind of get the idea of how some of the problems will look like. So you have two similar cylinders. They just give you the volume. They tell you, hey, the volume of one. Let me scratch real quick. The volume of one is 270 pi. The volume of the other one is 640. The height of the bigger one, our bigger cylinder, is 10. So we have a big cylinder. Oops, slanted, sorry. With the height of 10, and then a smaller cylinder with, we don't know the height. We know the volume though. This one is 640 pi, and the volume of this one is 270 pi. So you say, well, how are we going to find that? We don't have proportional parts. We don't know the scale factor. Well, let's find the scale factor. To do so, we just compare these two parts right here. All right, so 270 pi over 640 pi. If we can reduce this, we can find our scale factor. So let's go reduce. So pi's cancel out pi's, and 270 over 640, they both reduced by 10. So these zeros come out, giving us 27 over 64. Now remember, this is in the form of a cube over b cube, but we want to just get an a over b. To do so, you cube root each side. So you cube root this, you cube root that. That just gives you a and b. Well, if you do it to this side, you have to do it to this side. So if you cube root 27, you ask, what three numbers do I multiply 3 times with itself to get 27? Well, that's 3. And the same thing with 64. Cube root of 64 is 4. 4 times 4 times 4 gives me 64. So this is our scale factor, our original basic scale factor, 3 to 4. So since height is a one-dimensional product, then we set that up. So we'll say, hey, 3 is to 4 as the scale factor of the smaller one, h, is to the scale factor of the big one, 10. And then we just cross multiply. We do so, we get 4h equals 30. You divide both sides by 4, you get h to equal 7.5 inches. Hopefully that helps out before you guys are gone or are still struggling. See you a different day.